Okay, in this video, we're going to be talking about exponential functions, somewhat informally. We are going to focus on a very specific part of exponential functions, which is the multiplier. It's a building block for using and writing exponential functions. So you need to understand the idea of a multiplier. Okay? We're going to take a look at an exponential scenario, but we won't actually formally build an exponential function for it. But we're going to try and move you from an old-fashioned way of looking at the problem to more of a newfangled way of looking at it, which is going to be, in fact, using this idea of a multiplier. Okay, so here it says, suppose that you buy a car for $22,000 and that it depreciates, which means it loses value, 15% every year. Create a chart that shows the value of the car as it depreciates over the first 4 years of the life of the car. Well, to do this process kind of the old way, it's something that pretty much a 6th, 7th, or 8th grader could do if they understand percentages, which means they're going to take 15% of the existing value of the car, and then they're going to subtract the 15% from the old value of the car to create the new value, okay? And then they're going to repeat that process to keep continuing to reduce the value of the car by 15% every year. Okay, so we're going to do that mostly on the calculator. And for the sake of this problem, we're not going to use pennies because we're talking about $22,000. We don't need to know pennies. So I hit the mode button, and your calculator is probably here in this floating mode. You need to move it over to the number 0 and press enter. This means you're going to round your answer up to 0 decimal places, so it'll give us whole numbers. Okay, Stack and Quit takes us back to the home screen. And I notice here in this chart where it says years after purchase and value of car. Well, the first one's really a freebie because years after purchase, when it's 0, it means the car is still new. So it's worth $22,000. So how do I do this on my calculator? Well, I start with 22,000 and I hit enter. Okay, a couple ways to do this. I'm going to try and do this a particular way here. And then the decently easy part is I'm going to take 15% of that by doing times 0.15, and that gives me 3,300. Key thing to know here is that the 3,300 is not the value of the car. It's how much value was lost off the car. So that means to find the value after this, I need to take 22,000 and subtract the previous answer, which was 3,300. That gives me 18,700. Well, now I'm going to do this repeat the process part, which means I'm going to multiply that by 0.15 to take 15%. Okay? And then I see that's going to be a smaller number now because it's 15% of a smaller number. But the value of the car after 1 year was 18,700 minus the previous answer, 2,805, giving me 15,895. Okay? Again, repeating this part of the process. I multiply that by 15% to see how much I'm actually losing. And in this third year, I'm going to lose $2,384 from the previous value, which was 15,895, minus the previous answer on my calculator, which gives me 13,511. And then just one more repetition of taking 15% of that number. I see now that I've lost 2,027 from my 13,511 minus the previous answer. And that takes the value down to $11,484 after 4 years. Well, this process is not the most efficient. I hope you see it has a repetitive nature. This brings into the idea of recursion, where we do a process sort of in a repetitive way using the previous answer. That's the nature of recursion. But I think there's an easier way to do this problem, okay? And you realize here, although I multiplied by 0.15, that's not really the idea of what I'm going to talk about as being a multiplier, okay? The one thing in this process I hope you saw I did was subtraction. Okay, and that makes sense because when we subtract, it means the value is going to get smaller. Okay, And given that the car is losing value, that makes sense. But let's try and look at this a little different way. Okay? Same problem. I'm going to say we're going to use a multiplier. Okay? And using the multiplier is a little different. The first thing we're going to do is compute 100% plus or minus the percent change. Okay? And in this case, it's obviously going to be minus because the car is losing value. Okay? And then we're going to convert the percent to a decimal. This is the multiplier. Okay? And then we're going to multiply the original value by this number. And then from there, you are going to get the repetition again. So it's actually easier to do than to actually say the steps for. So the one thing you notice here is the car still starts at $22,000. So let's compute this multiplier by taking into account the change. Okay? Loses value means we're going to do subtract here instead of plus. And the 15% is our percentage change. So I get 100%, which all multipliers start at, minus 15% equals 85%. Now, why am I interested in 85% as opposed to the 15%? Well, the 15% tells me about the loss or the depreciation. I'm not interested in that. If you notice my chart talks about the value of the car. Well, the way you need to look at this, and I think this can be decently intuitive, if you become intuitive once you say it once or twice. Well, if you lose 15% of value, you still have 85% of the value. Okay, so the 85% is the number of interest. Okay, this is the value remaining. So if you're just going to take 15% and subtract it from the total, if the total is 100%, you're more interested in the fact that it's 85%. So really what we need to do is just convert that to a decimal. So we're going to make it 0.85. And this makes sense that it's going to shrink our value because we're multiplying by less than 1. And this is the part that replaces subtraction in the process. So we're going to multiply the original value by this number. So on my calculator, we're still going to be in this whole numbers mode, so I don't change that. I put 22,000 in, hit enter. And now I just have to multiply by 85%, which is 0.85. So we notice here that I've reduced in value, but I don't see the value I lost. I see the new value of the car. And if I hit second enter, I can just hit enter actually, but I want to make the point I'm going to take that answer and multiply it by 0.85 and so forth. I'll copy these values in, 18,700 and 15,895 and 13,511. And then again, if I just hit enter, it'll repeat the last command, which was answer times 0.85. You see I get 11,484. Now, the thing to notice here is that these are the exact same numbers that I got when I did the subtraction method. So here, instead of subtracting, I'm actually using multiplication, which is pretty cool if you think about it. I'm actually reducing the number by multiplying it by a number less than 1. So this idea is a lot more efficient, I think, because if you're interested in the value of the car, you should be working with a percent that tells you the value of the car as opposed to what you've lost off the car. Okay? So that's the idea of a multiplier in a pretty full example here, I'll call it. And if you notice here, the one thing where I can get you thrown off a little bit about is it plus or minus. Okay, so we're going to do a couple more examples and talk about multipliers in general here without being in a full word problem. Let's talk about what we would do to compute multipliers given these scenarios. Okay, these scenarios have to do with growth as well as decay or depreciation. Okay? And we'll just take a look at those. So suppose you have a situation that involves any of the following. Okay? How will we determine the multiplier? Well, for 22% growth, we're starting at 100%. Growth means add 22%. So this means we'd be using 122%. But you need a decimal. So I'll swing the decimal point 2 to the left and get 1.22. Well, to me, this intuitively makes sense because multiplying by more than 1 is going to create growth. The one that you see here, I hope you realize, is the 100%. The 0.22 is the 22 additional percent. So that should make sense with a little thought. So for 15% decay, I'm still going to start at 100%, but decay means it's going to get smaller. Okay? So we'll do subtraction, giving us 85%, which was the example we used in the problem. And as a decimal, that is going to be 0.85. Okay? Now, a lot of kids in this next example where it says 8% growth, they go, oh, it's 1.8. Just they kind of spit it out because they realize it's got this 1 in it and point and something to do with the given number. Well, this isn't true. You need to go a little bit more slowly. Just keep using the method I'm using by writing 100%, identifying if it's add or subtract by growth or decay, putting the percent change. If you notice here, this is 108%, which is not 1.8, it's 1.08. Multiplying by 1.8 would make something grow much more quickly than 1.08. Okay? So I actually want to turn this next one, for the sake of argument, into a decay problem just to balance out the examples here. Okay? So 4.23% decay. This would give us, starting again with 100%, subtracting 4.23% is going to give us 95.77%. Now we got to be a little careful here because this percent has a decimal in it, but in the end, we just use the rule, swing it twice to the left. We're going to get 0.9577. Okay? I think intuitively this makes sense because 4.23% is kind of a mild decay. And when you multiply by this number, it's multiplying by a little less than 1, so it's going to give you a mild decay or a mild depreciation. Now 100% growth, I'm going to do this very formally. Growth is add. Just be careful. 100% plus 100% equals 200%, but you need to make sure that you swing the decimal point and you see that the multiplier is just 2.0, or 2 that's fine. Okay? But you have to be careful though. It says 100% growth. People think you multiply by 1. Well, multiplying by 1 doesn't change the number, the initial value at all. Okay, now for the value to triple, this is a little different. Okay, yeah, you can't just be so mechanical with these ideas. But a value that triples is pretty simple. Tripling means you're multiplying by 3. So the multiplier is just going to be 3. Okay? Now the one thing that's a little different about this problem, it doesn't indicate a percentage change. So I didn't use this method of 100% plus or minus. But you do have to figure out, well, if a value is tripling, well, what are you multiplying it by? 3, because you'll hear that in some word problems. Well, I hope this addresses the idea of how multipliers work. It is a building block for using exponential functions in terms of writing them. Okay, you have to understand how a multiplier works. Be patient, be careful with your decimal point, and I hope you realize that using this multiplier is going to replace the idea of taking a percent and adding it or subtracting it from an original. It's actually much more efficient. So feel free to watch again. Enjoy. I hope this was helpful.